that about wraps it up. Thank you. If there are questions, anyone have a question? Yeah. Tim. Yeah. Believe it or not, there are plenty of send and receive objects in there as well. I think I realized early on that as one of the things I didn't really understand about pure data, and I think I do now, is the hash table. So everything is connected via this hash table, am I right? That's how information gets from one object to another. So it doesn't really matter whether you use send and receive or whether you use connections. But I think the idea was mainly to have blocks of code. You notice everything's on 4 channels, it's reproduced on 4 channels. And so to just create big sort of islands of code, I think it's just habit as well. I'm used to working like that. I'm used to making things that look messy but work. Yeah, maybe it could benefit. There's lots of things it could benefit for. I could benefit from a holiday from this patch, but it's very, very nearly finished, so it's coming. This patch has made me physically ill. I'm not kidding. But it will be worth it, just in terms of my own development, because I want to then, I want to proceed and now start to create interactive applications on the iPhone. Plus, the record label bought me an iPhone, so, you know. And they're paying me, so it's not so bad. Yep.
Maybe you explain to us, but my English is not good enough.
Mm-hmm.
In the last project, when the score is created,
Yeah.
do you talk about the rules that you apply to create the new score? There is something like rules that you can
Absolutely.
define some parameters?
Absolutely. This is another one of those projects that I thought was going to take 4 weeks and took 9 months. There is a single object. Let me go back to the actual. Let's look in detail at one of the examples. Score language. There we go. So basically GemNotes consists of a set of abstractions and an object here called GemNotes counter. And GemNotes counter is literally a counter. It's a hierarchical multi-level counter that counts the beats in the beamed group and counts the beamed groups in the bar and counts the bars and so on. There's several levels of counting going on there and can adapt reasonably well to time signature changes. And basically that rules everything. What's happening from that is you'll see there's a bunch of lists. There are several lists of numbers coming out, and they go into these abstractions. And these abstractions generate objects. So this is using PD's capability to actually generate objects on the fly. You can build basically self-building PD patches. I'll show you what happens when we just create the stave there. The staves are another set of objects. So there's a stave, you see. That's a stave. It's all done using fonts as well. So I adapted an open source font for music notation. What we'll do is we'll generate some notes here, and you'll see them appearing both, well, okay. I'll see how much I can cram this onto the screen. They'll appear both in the patch at the bottom and also on the stave on the right. So let's make a note. So there's a note, there's a bar. Oh, 2 bars, one on top of the other. That was 2 bars. Yes, very silly. There we go. And it's generating the objects and connecting them together. The counter is not only storing the hierarchical order of the objects, but it's also storing the number of objects generated. Because in order to do this, you have to know exactly where you are. So if I generate a new object now, I have to know what number object it is in the patch so that I can connect the inlets and the outlets to it. That beamed group doesn't look very well, but never mind. So the idea is that this is really using pure data to build a patch that would represent the score, basically. So PD is building its own patch within the abstraction. And the actual objects themselves are, okay, so here's a note, and it consists of all of the options you might have on a note. So there's a note head, a tail or a beam. The beams were, that was difficult, getting the beams. There's even tuples. I don't think they work properly yet. There's the beams, and the beams are rectangles that are sheared to meet the different note stems. So there's, so the idea is you start off with an object that represents a note, and then you connect it to a stave, and that's how you get a fixed musical score. But to create a generative musical score, you get PD to add objects to the stave and then connect them. And there is actually a path from the top, which is the stave, all the way, a GEM pointer list path that goes all the way to the actual objects themselves. So that's what generates the notes.
So, but the rules that decide if it's a do or a re,
Uh-huh.
it's arbitrary, it's random.
Uh,
There are some rules behind generating of the score, the notes.
Are you talking about the rhythmic rules or the pitch rules? The pitch. Yes, I haven't got, this is version 0.1. I'd say it's alpha. I haven't yet got to the point where there are key signatures, if that's what you're asking. So key signatures are on my ever-growing list of things to do. For now, there is a basic principle of showing every accidental and saying we're only going to have either flats or sharps, which is a compromise, I know. Fine for Mozart, not very good for Messiaen. An algorithm being used to generate pitches. No, they're just these messages here. Oh, in my piece. Well, there's a language that goes with it. So there's a language that you give the make voice object. You see these lists here? We've got bar 6, 8, 3, 8. What that says is we're going to have a bar of 6, 8, and the beaming is going to be 3, 8. So that's this one here. It's very fuzzy on the screen, and I can't zoom in, I'm afraid. But there we got bar 7, 4. And so the language is, it's a system whereby the language to drive the system was created along with the system. So that the object that counts all the objects responds to this language, you see. So it's like designing a new language of computer music. You have to design, if it's a script-based language, you have to design both the machinery to run it, the engine, but also the language that it's going to understand that tells it to run. Which is, in a funny way, a similar process to this, because you have a GUI, which is a self-contained program that does a certain number of things, and then you have a language of symbols and information types that you pass between the GUI and the pure data patch. And so it's similar, except that, well, because I made both, I get to dictate what the language is. I mean, these ones down here are the notes, and they're MIDI pitches, basically. What information does a note have? I think there's an earlier example that, yeah, let's look at that one. Let's get rid of that. This isn't about the language so much. This is more about what a note can have. So, there we go, a flexible note. It's not ideal. This is a proof of concept. It works, and I've used it in performance. But I think there's a lot of work to be, a lot of development work to be done to make it more usable. Yeah. Key signatures would be nice as well. Sharps and flats at the beginning of the bar, and then none of those messy accidentals that get in the way. That would be nice too. But just to give you a quick I'll show you the source code for that GemNotes object. Again, that was another one where I nearly, pulled out my hair, but. So yeah, this project also made me physically ill. I've got a number of things up there as well, like a matrix of default splits. So if you just give it a time signature, then it will go, right, we've got that many notes, so I'm going to say these are beamed, this group is beamed, and then this group is beamed. Then I'm going to move on to the next bar. But the actual counting mechanism is pretty complex. And that's just to encode rhythm. So there we go. Okay. Thank you.